All right, so we are going to do scientific notation now. Start off with, we're going to have a definition. So scientific notation, I'm going to write again, so we can put in a definition and some rules that go with scientific notation. So scientific notation was created so we don't have to write out lots of zeros for very large and very small numbers. So my definition for this is a shorthand for very large and very small numbers. So it's a shorthand, it makes things easier. And then there's a rule for how we can do scientific notation, and the rule has to do with being able to compare them and being able to later on do some operations. Next week we're going to multiply and divide in scientific notation, and so you want everything to be that way to start with. Okay, so the rule when you are putting things into scientific notation, this is the setup. It's going to be, let's put in some examples. Let's say I have 5 times 10 to the 7th. Okay, this number right here has to be between 1 and 10. I think it actually can be 1, but it can't be less than 1 and it can't be bigger than 10. And you will have, yeah. And then this number is positive for your large numbers, and it's negative for decimals. So your very small numbers. My arrows look kind of funny. So it's positive for large numbers, negative for small numbers. And so that's sort of the rule that goes along with it. If we were trying to do 5 times 10 to the 7th, we would start with 5. And we'd put our decimal place right after 5 because 5 is in the ones place. And then we're going to jump that decimal 7 times. So you go 1, 2, 3, 4, 5, 6, 7. Make a new decimal place. And you just fill in everything with zeros. So this one, if we rewrite it, I have 1, 2, 3, 4, 5, 6, 7 zeros. So 5, 2, 3, 4, 5, 6, 7. I don't know why I put a comma there because I don't think that's where it goes. So we're going to get 50 million. And so that's an example of a very large number. Okay, so we need to be able to go back and forth between what's called standard form, sometimes they'll call this decimal form, and then scientific notation. So we're going to practice going back and forth a little bit, and it's all about just moving the decimal place one way or the other. So what we're going to do first is start with a standard number, 67,900,000. So write down 67,900,000. So when we're writing this in scientific notation, you start the decimal at the end of your whole number, and we figure out how many jumps it's going to take so that there's just one number left to the left of the decimal point. That's how you get it between 1 and 10. So we jump 1, 2, 3, 4, 5, 6, 7 places, and I want to leave one number to the left. So I'm going to have 6.79, and we leave off all the zeros that are going to come after these two decimal numbers because they're not super important. And then we need to figure out how many places that we skipped. So 1, 2, 3, 4, 5, 6, 7. So that makes this times 10 to the 7th. You have to have the 10 in there because the 10, we have a base 10 decimal system, and when we move left and right, we're actually changing powers of 10. So that's the scientific notation.
In binary, you can do scientific notation for powers of 2?
I have never tried to do scientific notation in binary. I don't know if that exists. That would be a little interesting. I don't know. My answer to that question is I don't know. Okay, so then let's do another one. Let's do 100 and, let's see. Let's do 140 billion. So 140, 3 zeros after that makes 1,000. 3 more makes million. 3 more makes billion. Scoot this up. And we're going to change it into scientific notation. So I'll draw a little arrow showing that we're going this way. So my decimal is at the end of my whole number, and we're going to jump it back 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 places. So you could go ahead and put 10 to the 11th up there because that's how many places we jumped. And then the number in front would be what?
1.4.
Just 1.4 because the rest of it was just zeros. I have seen scientific notation use the X for multiplication and sometimes the times dot. I kind of like the X for this because there's a decimal place over here and it can get a little messy if your handwriting's not great. Okay, so those are some examples with some positive exponents. Now let's look at some decimals. So I'm going to start with 0.0000021. There's 5 zeros after the decimal and then 2, 1. And sometimes they will have this 0 over here, so if you want to put the 0 before the decimal, you can. And we're moving the decimal a different direction. So we're moving it to the right. We're going to move it to the right. 1, 2, 3, 4, 5, 6 places. I'm going to stop when I have 2 on the left side of the decimal point. So I'm going to have 2.1. I need to have something in that whole number spot. And then how many places? 1, 2, 3, 4, 5, 6. So times 10 to the negative 6th power. Now how did I know that it was negative?
Because the decimal goes.
Because a decimal. So remember that the negative powers go with the decimal. That's how we can tell. And then let's do one more of those and then we'll go the other way. Let's do 0.00386. And then if you want to put the other 0 on the other side of the decimal, it is good to have something in that place. So how many jumps are we going to have to make? 3. 1, 2, 3. So I know it's 10 to the negative 3rd. And then I'm going to have, I put my decimal there, I'm going to have 3.86. Scientific notation works best if you don't have a whole lot of digits that you have to carry out. You guys saw in some of the examples when I was gone that if there's not a lot of zeros but there's lots of digits, it's not necessarily easier to use scientific notation. What they do in a lot of times then is they'll round the number off and then turn it to scientific notation. Okay, so I'm going to do a couple where we're going to start on the right-hand side with scientific notation and go to the left. So I'm going to do 1.35 times 10 to the 5th, and we're going to take that back to regular numbers. So we'll start with the 1.35. I'm going to make my decimal point kind of not very bold because we're going to move it. So my decimal's here, and I'm going to jump until I'm going to make 5 jumps to the right. So since this is positive, it tells me it's going to be a large number, which means I'm going to make this bigger by moving the decimal place to the right. So 1, 2, 3, 4, 135. So we'll fill in all of the missing pieces with zeros, and we actually get 135,000. I'll write it neatly kind of underneath there as the final answer. Since that was a positive, I knew that this was going to be a bigger number. And let's do one that has a negative. So I'm going to skip down a little bit. This will be the last one. Let's say I have 0.0027. And I'm sorry, I did not mean to do that. I was giving you the answer instead of looking at the... So I'll make up a new problem. It'll be fine. Let's say I have 3.2 times 10 to the negative fourth. So what we do with that is we'll start with the 3.2, kind of making that decimal not really bold. And since this is negative, I know that this is going to be a decimal, and so we're going to move it to the left. So I'm going to move it 1 place, 2 places, 3 places, 4 places, make the new decimal, fill in with zeros. So I'm going to get 0.00032. And then if you want to put another 0 on the other side of the decimal, you can. And that's the end of that.